The aim of the experiments is to find out how to make yogurt and what types of bacteria is in it. The set of experiments that will be shown is about making yogurt and to find out what type of bacteria that is in the yogurt and how they affect our body systems. The method to making yogurt is to put 10 millilitres of fresh milk into a sterilised test tube and to incubate it at 80 degrees in a hot water bath for about 30 minutes. This is to sterilise the milk to make sure that any harmful bacteria are no longer in the milk. The next part is to incubate test tube in a 45 degrees hot water bath for about 15 minutes, so any good bacteria can survive in the milk and help create the yogurt. Using aseptic technique to transfer the milk into a sterilised vial, and using the same technique to transfer 5 millilitres of live yogurt bacteria into the same vial. After putting name and the day onto the vial and after taking the picture, it goes into an incubator which is at 28 degrees for 24 hours. After 24 hours, the vial being in the incubator, the vial goes into the fridge which is at 4 degrees. Plate streaking. After getting the vial from the fridge, tap the bottom of the vial to get the yogurt culture into everywhere else. Light a Bunsen burner and using the thumb and index finger of your right hand, put the incubation loop into the blue flame and wait until the loop turns red hot. This is to kill any and all bugs that are on the loop surface. Also slightly flame the handle as well. This is to minimise the chance of contamination. Cool the loop for about 5 seconds, and while the loop is cooling, with the left hand that is holding the vial, take off the lid using your right hand and quickly pass and rim of the vial through the blue flame. Carefully dip the loop into the yogurt to collect proisms. Collect the cells to be streaked. Do not touch the side of the vial, and the part that went through the flame should be the only that should touch the yogurt. Flame the neck and rim of the vial and put the top back onto the vial. Make sure the top never comes in contact with anything but air. After putting the vial back, pick up a petri dish with your left hand and flip the cover plate. Gently stroke 3 to 5 parallel lines in one corner of the plate with the loop to spread the cells. Put the cover plate back on, then flame the loop and cool it for about 5 seconds. After opening the petri dish, spread the cells further with 5 to 6 strokes, starting each stroke by crossing the original set of lines. Repeat this twice more to spread the cells more. These next set of pictures show the bacteria that have grown. Very little has been grown. Staining. After getting a clean glass slide, put a small drop of water into the middle of the slide. After sterilising the loop using the Bunsen burner, let it cool for 20 to 30 seconds. Then use the loop to pick up a small amount of bacteria from the surface of the agar plate. Also making sure not to dig into the agar plate. Put the loop full of bacteria into the drop of water that is on the slide and rub the bacteria into the water. Sterilise the loop again to kill any remaining bacteria and let the smear air dry completely. making sure not to use any other heat. After the slide has dried completely, heat fix the slide, and this is to hold the slide at its edges and pass it through the Bunsen burner about 3 to 4 times. Gram staining. After putting the slide with a thick smear onto a staining rack, which should be pointing to the ceiling, and the staining rack should be over a staining tray. The staining rack should be over a straining tray. Cover the smear completely with crystal violet solution, and this should be left for 1 minute. Hold the slide at an angle over the straining tray and pour off stain by washing off any remains and any that's on the back of the slide with iodine solution. After putting the slide back onto the staining tray, cover the smear with iodine solution and leave it for 1 minute. The iodine solution acts as a moderant, and this is a component for a staining process that helps the stain to adhere to the specimen. A crystal violet iodine complex is formed and the smear looks black. Hold the slide at an angle over the staining tray and wash off the iodine solution with ethanol. Continue treating with alcohol until the ethanol wash turns pale violet. Rinse the slide immediately with water and put it back onto the staining tray. Cover the smear with the saffron solution for 30 seconds and rinse it off with water. Lastly, take the slides off and blot dry it. Then put it under the microscope and look at it before and after using oil emission. When finished, dispose of the slides. Discard jar. The conclusion is that there is gram-positive bacteria in the yogurt because the bacteria retained its colour of the crystal violet used during the gram staining. Gram-positive bacteria are helpful because they live in our gut and help us digest our food. The method used at an industry scale is to first modify the milk to reduce its fat content. Then it's placed into a storage tank and it's tested for other stuff. To get the milk to the right level of consistency, water is either evaporated off or milk/milk powder is added. This is done to help yogurt firmer and to improve its stability. Pasteurization is next, so after everything is stabilized. This step is to destroy microorganisms in the milk. Also is to determine the proteins in the milk. Pasteurization involves heating the milk to high temperatures for a long time. While it's at a high temperature, the milk starts to get broken down into small particles. This melts the yogurt. This makes the yogurt smoother and creamier. Ferment is when pasteurization is complete and the milk is cooled a little bit. The culture is added and it is held at the same temperature for 3 to 4 hours while the incubation process takes place. This is to get the bacteria to metabolize in the milk to produce the yogurt flavour. Lactic acid is a byproduct of this process. This is all done in a large tank, and when the yogurt is ready, it's poured into its containers. All of this is done at a large scale. The method that was done in the lab was more or less the same method. The conditions used to prepare the yogurt can affect the quality because the milk is heat treated then cooled to allow the addition of bacteria or starter culture. If the temperature is right and there is moisture, the bacteria are able to ferment the lactose, producing lactose acid. The milk proteins change from a solid/semi-solid state to form yogurt. At the same time, a colourless liquid is produced during the process, and this gives yogurt its direct flavour. If none of this was right, then the yogurt wouldn't taste right and would be thrown away. Our gut contains tens of trillions of microorganisms, and this includes at least 1,000 different species of known bacteria, which has more than 3 million genes, and this is 500 times more than human genes. These bacteria can weigh in total 2 kilograms, and 1/3 of our gut bacteria is common to most people, but 2/3 of our bacteria are specific to us. Some of the useful functions are to help our body to digest certain foods that the stomach and small intestine intestines have not been able to digest. They also help with the production of B and K vitamins and help us combat aggressive microorganisms. They also play an important part in the immune system.